Welcome. Thanks for joining APA's webinar, Engineered Wood I-Joists, Fire Protective Assemblies and Firefighter Safety. My name is Greg Johnson. I'm the principal of Johnson & Associates Consulting Services. I am pleased to introduce my associate and today's presenter, Rob Neal. Rob is the owner and principal consultant at Integra Code Consultants, a Maryland-based firm providing code consulting, plan review, and training. He is the former Vice President of National Fire Service Activities at the International Code Council and Deputy Superintendent for Curriculum and Instruction at the National Fire Academy. A couple of notes before I hand it over to Rob. All lines are muted, so you will have to ask your questions via the question portal or chat box during the webinar. Questions and answers that we are unable to address today because of time will be available with the recorded version of the webinar on the APA website in about 2 weeks. This program is accredited by the AIA and the ICC for continuing education. A link to those certifications will be on the APA website about an hour after the conclusion of the webinar. Rob?
Well, thank you, Greg, for that nice introduction, and welcome everyone to today's webinar on engineered wood I-joists and fire protective assemblies for firefighter safety. I appreciate you taking the time today, and hope this works out to be something that you will take some good information back to your workplace with you. I'd like to start by explaining a little bit about who the APA is. APA was a non-profit trade association founded in 1933, representing at the time, and was called the American Plywood Association. But with changes in wood products over the years, they've adopted a more modern name to really recognize and address what they really do today, and that is engineered wood. They are the leading resource for information about engineered wood products throughout the United States and Canada. They maintain markets through excellence in their APA trademarked product promotion. They support quality assurance, and they provide much technical and educational support, not only for people on the webinar, but for anybody who has an interest in wood products. They represent 169 North American mills. And these mills include manufacturers that produce plywood, oriented strand board, glulam products, engineered wood I-joist, and structural composite lumber. You can find out more information about this particular project and other information from the APA by going to the website at www.apawood.org/fire. Today's presentation is going to be talking about residential construction and wood I-joists. In recent years, there's been a number of newsworthy events that have talked about the failure of these particular products and how they affect firefighter safety. And APA has gotten to the forefront of trying to solve this particular challenge. We're going to talk about wood I-joist fire protective assemblies and the requirements of the International Residential Code. We'll talk about APA's efforts to prevent civilian and firefighter injuries and deaths. We'll talk about how the wood products industry is engaging in firefighter safety. Not only do we have this webinar today, but APA and the American Wood Council both are doing a number of national presentations on firefighter safety and fire protection in face-to-face environments as well as through the online training. So let's start by talking about engineered wood I-joists. Wood I-joists became popular after they entered the market in 1969. There was a resource shortage of wood that occurred in the 1970s that drove additional development. It's interesting to a lot of people, they don't realize that wood I-joists are not less expensive than nominally sawn lumber that has been traditional in the marketplace for many, many years. Wood I-joists are successful in their performance because the growth of their product is valuable for contractors and developers despite their additional cost. Architects like them because they provide design flexibility with greater open spaces. Wood I-joist can be manufactured to a required length to create a much more open environment in residential types of construction. Now, traditional nominally sawn timbers, typically 2x4s that are used for wood floor construction, have span limitations that create or end up in consequences of having smaller spaces. The maximum floor span for a typical 2x12 nominally sawn lumber, 12 inches on center, is limited to only 20 feet 3 inches. Engineered wood I-joists can be manufactured in much greater lengths, up to 31 feet 7 inches, which allows for larger spans and wider open spaces. This illustration compares two types of I-joist products, one with solid lumber upper and lower flanges, the other with LVL, or laminated veneer lumber flanges. I-joist strength and stiffness are provided through three major categories: engineering, testing, and manufacturing quality controls. Engineered wood products include detailed analysis for wood grade quality, for thickness, for bond and adhesive classifications, for nail size limits, span limits, and moisture exposure. Products are tested for performance by independent third-party analysis, such as the U.S. Department of Agriculture, Underwriters Laboratories, and APA's own test laboratories, one of which is in Tacoma, Washington, the other in Atlanta, Georgia. As far as our manufacturing quality controls go, APA is accredited by the Standards Council of Canada as a certification body under ISO 17065 and accredited through the International Code Council International Accreditation Service as an inspection body under ISO 17020. Through these accreditations, APA provides certification to their member clients to conform to product standards as well as to APA policies. As part of the certification process, all clients are subject to ongoing audits of the client's quality control system, its internal inspection, and conformance to the product standards. You can identify APA trademarked I-joist through their Engineered Wood System Trademark Program. This signifies that the I-joist assembly manufacturer is committed to APA quality standards. Top cord stamp verifies the I-joist complies with PRI, Performance Rated I-joist Standard 400, the performance standard for APA Engineered Wood System I-joist. Other information that can be found on the top cord stamp includes the net I-joist depth, in this case 9.5 inches, the joist series, which is used for comparing joists to the permissible spans, and the plant number in which the I-joist was manufactured. Users like I-joist because of the following benefits. First of all, it's the material consistency. The materials coming out of the manufacturing plant are consistent in the quality and the design. They're lightweight and easier to handle. They allow for faster installation, and they result with less waste that requires less cleanup and disposal on the job site. These factors alone make them much more desirable in nominally sawn timber and help decrease the overall construction cost, even though the individual wooden I-joists themselves may be more expensive than nominally sawn lumber. The purpose of today's topic is to talk about fire. So let's talk about some of the fire studies that have been going on to understand how these items perform under fire conditions. What's changed in residential construction over the last few years? Well, several things have changed in the marketplace that have caused concern for firefighters and first responders. First of all, we're starting to see larger homes that have larger rooms. According to the Wall Street Journal, the average size of a home of a single-family dwelling that was built in 1970 averaged about 1,500 square feet. In 1990, that grew to 2,080 square feet, and in 2014, it was 2,657 square feet. This represents a 77% increase over that entire time period. Along with that, design elements have opted for more open space that increase the amount of fuel and ventilation that occur in a single compartment. Where older homes had smaller rooms that provided firefighters some protection from flames and smoke as they advanced into a building to fight a fire, but now with these increased floor plans that have open spaces, they don't have that protection as much as they used to. Another thing that's changed is furniture characteristics have changed over time. Furniture that used to be constructed of wood and natural fibers now may be made out of synthetic materials. And although home furnishings generally meet voluntary flammability standards, these pertain to ignition and surface ignition characteristics, not to the total combustion of the product themselves. These large open homes have greater floor, ceiling, and attic voids where fires can remain hidden for a few minutes until firefighters can get to them. And new building materials have changed the way buildings are being constructed. So what's the consequence of this? What's the effect on fire? Well, we have faster fire propagation. You'll see momentarily that some research has shown that fires grow faster than they did 20 to 25 years ago or longer. We have a shorter time to flashover. Now, flashover is a term that the fire service uses to describe every combustible material that's in a space igniting simultaneously. Flashover typically occurs at about 1100 degrees Fahrenheit, and no one can survive it, even firefighters in protective clothing when it gets to be that hot. The other consequence is shorter escape times, where people used to have time to respond to a smoke alarm or some other detection device in their home, perhaps explore what the cause of the fire was, and then get out. These shorter escape times, because of these new building materials and contents, are getting to the point where now, as soon as you hear your smoke alarm, you need to get out of the house right away. And the other thing we're finding is there's shorter time to structural collapse. Now, it's important to remember this is not just an issue with engineered wood I-joists. Engineered trusses and cold steel framing that are not protected from thermal impact also have these consequences. Several years ago, Underwriters Laboratories, a very well-known testing laboratory in Illinois, evaluating the performance of dwelling contents. They set two fires to measure the legacy versus modern contents of buildings to see how it affected fire behavior. And when they talk about legacy furnishings, they're talking about natural products, furnishings that were made of wood, that were covered in cotton and wool, and padding that may have even been horsehair or some other natural product. Compare that now to modern products, which have steel or plastic frames, and often are covered with synthetics, and often are filled with polyurethane or polystyrene foams, which are essentially petroleum products that have been made rigid. What UL's furnishing fire test showed was the time from flashover, from the time the fire was ignited in a legacy building, was about 29 minutes and 30 seconds, where in modern construction products, that time is reduced to 3 minutes and 30 seconds. This really verified and stressed the importance of early fire detection and early escape when it becomes a challenge. UL went on to do some collapse time studies on some of these products. They did test scenarios using various nominal and engineered wood floor assemblies. They did 9 full-scale fire tests using sawn wood, wood trusses, and engineered wood I-joists. They built compartments that represented small rooms and roof assemblies, and they installed 2 300-pound mannequins on top. The mannequins were intended to represent firefighters in full protective clothing, one of whom is standing on the roof and the other is crawling as if he were crawling across a floor or a ceiling, the roof of the building. Now, the tests were done with something called the ASTM E119 fire test protocol, which is commonly called the standard time temperature curve. If you take a look at the graph to the left, this test has been around since about 1918 and is used primarily to evaluate fire resistance of products that are put in commercial buildings. You've often heard of buildings having a 1 hour, 2 hour, 3 hour, or 4 hour rating. Well, this test is used to evaluate those products to see how long they'll perform under those conditions. And essentially what happens is a product or material is put into a furnace, the typical assembly being 2 layers of 5/8 inch gypsum wallboard on a 24 or 4 wood stud, placed in a furnace, and a fire set in this furnace to measure the performance of the product. As you'll see by the curve on the line there, fire condition starts out slowly, builds up fairly quickly to about 1,000 degrees Celsius, which is about 2,200 degrees Fahrenheit, and then continues over a very strong upward curve from 2, 4, 6, and even 8 hours. A product is put into this test. If it survives that temperature for a period of time, it gets a 2, 4, or greater fire resistant rating for use in commercial products. What you're going to see is because the test was done using products and test criteria that were done in the early 1900s, as we discussed, we're seeing materials and new construction techniques, there's a lot of question as to whether or not this is even considered to be a valid test anymore. So UL, in their collapse time studies, tested these particular products under these configurations. We'll go through and show you a little bit here about what the various collapse times were. So the first product they tested was an unprotected 12-inch wooden I-joist installed 24 inches on center. And remember, it was loaded with 2 300-pound mannequins and some other additional dead loads that represent the typical type of construction that's out there in the field. When set on fire under the standard time temperature curve, product collapsed in 6 minutes and 3 seconds. They compared that to unprotected, nominally solid sawn 2x10s, also spaced 16 inches on center. Most products collapsed in about 18 minutes and 45 seconds. Half-inch gypsum wallboard I-joists, spaced 24 inches on center, collapsed at 26 minutes and 45 seconds. Half-inch gypsum wallboard protected parallel core glue finger jointed trusses, 24 inches on center, also collapsed at 26:45. And half-inch gypsum wallboard protected nominally sawn 2x10s, 16 inches on center, survived 44 minutes and 45 seconds. Putting a half-inch layer of gypsum wallboard on a parallel cord truss, 14 inches deep and 24 inches on center, enabled it to survive 29 minutes and 15 seconds. And finally, half-inch gypsum wallboard 2x6 with a 2x12 pitch to represent a roof, spaced 16 inches on center, survived 40 minutes. Now, what's important to recognize from this is the I-joist manufacturers realized the importance that they needed to extend the time to burn through and collapse. And have worked very hard over the last few years to develop workable fire protection solutions that are economic and can be used in very easy conditions. Now, another test that was not necessarily intended to evaluate the performance of wooden I-joists occurred in the last couple of years here through what's called the UL-Firefighter Safety and Research Institute, which is located in Columbia, Maryland. They have been trying over the last couple of years to teach firefighters to use science and engineering to perform fire operations and not just rely on old tales of how firefighting ought to be. So they built some test criteria, some test labs, and set them on fire. Now here's a photograph of one of them installed, and what they were trying to do was to determine the exact way that basements fires performed or behaved so that they could actually come up with some firefighting tactics that made some sense. So they weren't, like I say, necessarily testing the engineered wood I-joists, but just serendipitously, they happen to have these particular products in the room. So if you take a look at this room, it was enclosed on all four sides, 6 sides if you include the floor ceiling assembly and the floor, and was outfitted with 2 pieces of modern furnishings, the polyester covered sofas that you see there. And then the additional wooden pallets were installed to provide additional fuel load representing other pieces of furniture that might be found in the basement. Now, if you look real closely at the edge of the left-hand side edge of the carpet, you'll see a line, vertical line in the picture. This represents what's called a thermocouple tree. Now, this is instrumentation that UL provided to measure the air temperature at various levels of the room after the fire was begun. And you'll see some data here on the next slide that explain how that data was collected. So in the first fire that they used, they built the room and set it on fire, and they had no fire sprinkler protection in that basement. If you look at the graph, you'll see here on the left-hand side, the vertical axis represents temperature in degrees Celsius, and on the right-hand side is the temperature in degrees Fahrenheit. Across the bottom, you'll see is the time in seconds when the fire began and what the temperatures were at various elevations from time to time. Now, if you think back to that time temperature curve that we saw for the standard time temperature curve that had a nice arc and went up over time, you'll see the fire behavior is different under this particular environment. The fire started, of course, at 0 seconds, and in about 200 seconds, it's about 125, 130 degrees Fahrenheit, but then it peaks very, very quickly to about 1100 degrees Fahrenheit, somewhere between 200 and 300 seconds after the fire. So it's basically within 5 minutes of the fire beginning. Then it goes and tapers off to extinction until after about 1400 seconds, the fire is no longer even a threat. The various lines that peak there, you'll see the red line represents temperatures at 2 feet from the ceiling, the green line at 3 feet from the ceiling. As you can see, as it reaches about 1100 degrees Fahrenheit, which is that flashover temperature, which is not survivable to anyone, even including protected firefighters. So the fire behavior is a little different from what we've seen over the years, and really results in some changes in the way we need to fight fire, as well as the way we need to provide protection for the various types of construction. Now, UL did a second test, and this time they used an automatic sprinkler system in the basement. Now, this was a residential sprinkler system, nothing that was all that sophisticated, not a lot of cost associated with it like you might expect to see in a large commercial property. In fact, it was provided with half-inch pipe, plastic pipe, and was supplied by a water supply that totaled 300 gallons. Typically flowed about 13 gallons a minute, so there was not a lot of flow in there. It's interesting to see, again, here how the temperature profile changes in that particular environment. Again, the fire was started at 0 seconds, and at about 150 seconds, just slightly over or slightly under 3 minutes, the first sprinkler operated and controlled the fire and kept the temperature down to less than 250 degrees. In fact, the peak temperature just before 5 minutes was 212 degrees. That was recorded in the lab, and it was certainly a temperature that's survivable not only for someone in just general street clothes, but also firefighters in their full protective clothing. Now, certainly, no one would want to be in 212 degrees for very long, but it is a survivable temperature. So this helped UL show and helped us understand that automatic sprinklers do provide a very viable solution for protecting the structural integrity of those floor ceiling assemblies. So let's talk about how this all affects the building codes. As I said, the APA, the Engineered Wood Association, and its members recognized how important it was to provide some means of protecting these floor assemblies to provide an additional time to prevent burn through and collapse. So in 2012, APA, in conjunction with several folks in the fire service and other folks, got a change to the 2012 edition of the International Residential Code, which is the primary building code for 1- and 2-family dwellings and townhomes throughout the United States. And this code change said that floor assemblies that are not required elsewhere to be fire resistance rated needed to be protected with a 1/2-inch gypsum wallboard membrane, a 5/8-inch wood structural panel membrane, such as oriented strand board or plywood, or some equivalent on the underside of the floor framing member. And again, this is intended primarily to provide a thermal barrier between the fire in the basement or the underfloor space and the structural members that are holding up the ceiling floor assembly to buy time for escape, as well as to help firefighters be a little safer when they enter the building to suppress the fire. Now, in 2015-2018, this particular section was moved to R302.13 of the International Residential Code and added some allowances for penetrations, recognizing that there were going to be ducts, vents, and electrical outlets and other devices that had to go into this membrane in order for the space to be functional. So this is essentially what the illustration of essentially what the International Residential Code says, is you have to protect lightweight floor systems in unfinished basements by attaching a membrane of a 1/2-inch gypsum wallboard, 5/8-inch wood structural panel, or some equivalent. Now, it's important to point out that the 1/2-inch gypsum wallboard is just simple standard drywall. It does not have to be Type X fire-rated drywall. It's just simply a gypsum wallboard that you could buy at any home improvement store. So here's the typical way of doing it. You protect that lightweight floor system by attaching the membrane to the bottom of the joists. You use 1 1/4 Type W drywall screws spaced up to 12-inch centers. And in this level of protection, the joints don't even have to be protected. You don't have to apply tape and mud to provide a finished surface. You're basically just providing this 1/2-inch thermal barrier underneath the bottom side of the engineered wood I-joist. So again, just to provide protection for not only the bottom cord, but the flange in the middle, which is the thin part there that would be susceptible to heat and flame impingement. Now, there are some exceptions in R302.13 where the gypsum wallboard or the wood structural panel is not required. First of all, as we saw from the data that the UL Fire Service Research Institute provided, if the space is protected by an automatic sprinkler system, you do not need to install the fire protective membrane. And it's also interesting to point out or to know that CPVC, chlorinated polyvinyl chloride, and PEX, cross-linked polyethylene sprinkler pipe, are now listed to be exposed under the engineered wood I-joist. So there's no longer a need to provide a thermal barrier between the sprinklers and the floor assembly, because the sprinklers provide that level of protection that's satisfactory to support the structural integrity of the engineered wood I-joists. A second exception is if you are in a jurisdiction where the International Residential Code has adopted Section R313 for residential sprinklers. That basically takes care of the entire issue in terms of whether the material is exposed or not. We provide sprinklers in all parts of the dwelling area, and then you have the protection that's automatically built in. Now, in those jurisdictions that may not have adopted R313, the fire protective membrane requirements are ignored, or I shouldn't say ignored, but avoided if you provide a framing protection option for residential sprinklers in the unfinished basement. And again, that's the data that we showed you earlier that the UL Fire Service Institute proved in their test that an automatic sprinkler system under those unfinished members do provide satisfactory protection for the framing. Another exception for membrane protection requirements is under floor assemblies that are located directly over a crawl space that is not intended for storage or for the installation of fuel-fired or electric-powered heating appliances. So as you see in this illustration here, crawl space underneath there, the theory is that there's no fuel under there that's going to cause a fire that would threaten the engineered wood I-joist, and so there's no membrane protection required there. A third exception is for small portions of floor assemblies that are less than or equal to 80 square feet. What this does is it allows for the installation in congested areas where wallboard or wood structural panels may be difficult. This, for example, here in a mechanical space in an unfinished basement where you have water heater, furnaces, other equipment, air conditioning equipment, plumbing, you're allowed to have that space exposed to the engineered wood I-joists because it would just be too difficult to try to put wallboard up there and not penetrate the membrane. The code does require that that space be fire blocked in accordance with the International Residential Code to separate that unprotected portion of the floor ceiling assembly from the rest of the floor ceiling assembly that is protected with the gypsum wallboard. Now, a fourth exception to the membrane requirements addresses the fact that wood floor assemblies that use dimension lumber or structural composite lumber, an APA product, that is equal to or greater than 2 by 10 nominal dimension does not have to have the gypsum wallboard or orated strand panel or plywood membrane installed on the floor ceiling assembly. It also addresses other approved floor assemblies that demonstrate equivalent fire performance. And that's what we're going to talk about as we go through here, is what APA has done to show how this fire performance can be provided through other assemblies that may not necessarily meet the specific requirements or the specific prescriptive requirements outlined in the IRC. So in summary, any floor assembly has to be protected by a gypsum wallboard membrane or an oriented strand panel or plywood composite panel if it doesn't use dimensional lumber or structural composite lumber equal to 2 by 10 or greater. The area under floors must be protected with sprinklers or the membrane. We talked about that being a 1/2-inch gypsum wallboard with a wood structural panel at 5/8 inch. Also, the crawl spaces that do not contain fuel-fired or electric appliances, such as furnaces and hot water heaters, or not being used for storage, do not need to have the membrane. Small areas less than 80 square feet maximum do not require the fire protection, but do have to have fire blocking in such a way that a fire occurring in that mechanical equipment will not threaten the rest of the protected structure that has been provided with the membrane. So how do we know this stuff works? How do we know that these materials have been tested and evaluated, and the code official who's going to be installing them has some level of comfort that he or she is approving a qualified or a competent product? Let's talk a little bit about some of the test criteria and reports that they use. Now, it's important to know that fire protection equipment and materials go through a rigorous third-party testing in the United States. Now, the U.S. is unique in the world that we are one of the few developed countries that do not use government-mandated, or I should say federally mandated, building codes and standards. All the test standards, building codes, and fire protection codes in the United States are developed through a consensus-based process. And the test standards to which these materials are evaluated also go through a similar process. So what happens is manufacturers, code officials, fire service design professionals, contractors, product manufacturers, developers, everybody can get together and participate in the process. And they develop a performance standard that is used to evaluate these particular products. Now, to assure the integrity of the standard, that it's not biased toward one market or one particular product, the standards development organizations go through and have their standards accredited by the American National Standards Institute or some other organization. Once the standard has been accredited and recognized, then the tests for the particular products are performed by what are called OSHA-approved, nationally recognized testing laboratories. So organizations like Intertech, UL, FM Global. These are the sorts of folks who do tests on these products to evaluate them to verify that they perform in accordance with the test criteria and are satisfactory to meet the safety standards. And then finally, these test criteria get adopted and referenced in the code, and this is where the local code official can refer to the test criteria and have some confidence that the materials are being tested and evaluated in a way that is recognized by the national standards. One of the product's service evaluation and organizations is called the International Code Council Evaluation Service. They are a member of the International Code Council's product or family of companies, and they have developed acceptance criteria 14, AC 14, that is used to establish the equivalent fire performance of other products and methods. It's the one that establishes the 2x10 nominally sawn or strand lumber benchmark for thickness and performance for fire conditions. It uses the standard time temperature test, AST and E119, to evaluate the products. The products are loaded joists that are filled with holes, recognizing the fact that ducts or pipes or other products may have to go through these wooden I-joists. And the AC-14 also evaluates the durability and quality requirements of any of the factory installed protections that might be used to satisfy the fire resistance ratings that are going into these particular products. So APA jumped on board with this. In fact, it really led the fight on all this stuff by taking a look and creating the ESR, what they call their Engineer Service Report. ESR 1405 is their verification of the report for their I-joist assemblies that meet equivalent fire performance. They also produced a document called APA Systems Report, SR 405, that describes prescriptive assemblies that the contractor or developer can use that meet the fire protection requirements of wood I-joist floors. Again, these are available for you at no cost at www.apawood.org. And so these are the reference reports that can be used to verify product quality as well as fire resistance and structural integrity. So here are some of the designs that they recognize. Now, first, again, we talked about the automatic sprinkler system protection. Now, when we go through the 7 designs that APA recognizes as being equivalent, the sprinkler protection is a generally accepted exception to all of the fire protection designs. And again, it's important to know that CPVC, chlorinated polyvinyl chloride, the orange stuff, and cross-linked polyethylene pipe, PEX, is listed for use under exposed engineered wood I-joist. So this provides a relatively low-cost option for providing structural protection for this type of framing. Let's go through the fire protective membrane requirements that the APA prescriptive assemblies recognize. First is Fire Protection 1, which is where we talked earlier. You protect the lightweight floor systems in an unfinished basement by simply attaching a membrane to the bottom of the joists. And here you use half-inch gypsum wallboard that's attached with 1 1/4-inch Type W drywall screws, spaced 12 inches on center. No finishing is required whatsoever. Just the screws holding it in place are all that's necessary to satisfy the alternative protection method in the International Residential Code. FPO2 is where you actually apply the gypsum wallboard to the cord or the flange of the joints of the assemblies and provide protection in between the flanges. If you take a look at this particular building this particular assembly has a minimum flange size of 1.5 inches by 2 inches, and then the gypsum wallboard, the half-inch gypsum wallboard, is installed in the flange area itself. And what this does is it recognizes the fire resistance of the wood in the flange, and then adds the fire resistance to the gypsum wallboard to the nominally 3/8 inch flange size inside the engineered wood I-joist. A second method of doing it, if you have smaller flanged I-joists that are typically minimum 1.8 inches by 1 3/4 inches, is to overlap the entire engineered wood I-joist itself with half-inch gypsum wallboard. You see here the difference between the two is where the previous FPO2 simply protected the flange. this particular design protects both the bottom and top flanges as well as the cord itself. So this provides a little bit of extra fire resistance in there, and perhaps is easier to install rather than cutting and shaping all those different pieces of wallboard to go in there. The fourth method, or all these methods actually, include recognition that there's going to be some holes in the web where you attach the wallboard to provide access for plumbing, ductwork, and other pieces of equipment that might go through these engineered I-joists. So the wallboard gets attached either to the web or to the flange, as we discussed in the previous slides, to provide that fire-resistant protection. Now, another option exists is the installation of mineral wool. If you use 2-inch mineral wool and rest it on the upper side of the bottom flanges, you can use this as a means of protection, specifically if the flange size is 1 1/8 inch thick by 1 3/4 inches wide. Now, it's important to note that these require stay wires that are installed on not greater than 24-inch centers to make sure that the mineral wool itself doesn't sag or fall out unintentionally. Another product that's recognized is what's called proprietary ceramic fiber blanket insulation. Now, this is not just fiber blankets that you can go to the home goods store and buy something and staple it in. This is actually a specific product by one of APA's member companies. It's a ceramic blanket that gets stapled in there every 16 inches on center, and it's stapled to the inside of the I-joist to the cord itself. This provides a quick operation to install, and it perhaps is easier than cutting and placing all the gypsum wallboard that the other options talk about. Now, there's one option that's become very, very popular, and that's what's called a drop-in approach, and very similar to a drop-in ceiling tile. These two approaches, FP06 and FP07, which were just approved in July of 2017, can be used using gypsum wallboard as a way to protect the thinner part of the engineered wood joists, and providing protection that enables access to these places. So if you have pipes or ducts or wires or other items that are running through the engineered wood I-joist, this is a solution that might work very, very well for you. The other thing that's nice about this particular solution is it can be done at any time. It doesn't have to be done when the framing is being installed. It can be installed after the building is getting ready for occupancy, and can be done essentially at any time during the construction. So if you note here, the joist spacing in this particular option is limited to 19.2 inches. It uses 1/2 inch gypsum wallboard, and you'll see that the wallboard is then cut to fit in that gap between the two. The right-hand column talks about the required length or width for the gypsum wallboard, ranging from 11 1/8 inch to 18 3/8 inches, with a factor of plus minus 1/8 of an inch to be able to get it to fit in that particular space. So there's a little bit of a gap between the gypsum wallboard and the flange of the core of the joist itself, but it's the level of protection that's provided by the gypsum wallboard is adequate to protect that. This is used for minimum flange sizes of 1 1/8 by 2 inches. Now, FP07 uses 5/8 inch gypsum wallboard and goes to greater spacing allowances for the I-joists that are spaced up to 24 inches on center. Again, so you can see here we're using 5/8 gypsum wallboard. Your joist spacing can range from 12 to 24 inches, and your widths or lengths are from 11 1/8 to 23 1/8, with a plus minus variance of 1/8 of an inch on all of them. Again, the minimum flange size in these particular cases is 1 1/8 by 2 inches. Another mineral wool option is to use 3 inches of a proprietary product in joists spaced up to 24 inches on center. Again, this is a product that's recognized by APA members and has to be installed much like the gypsum wallboard, but is resting in there on the bottom flange, and also has to have stay wire supports 24 inches on center. And minimum flange size for these is 1 1/8 by 2 inches. Now, other products that might be out there that you might encounter that you need to be concerned about, or at least be aware of, is one of which is a factory installed protection or a coating. It's important to recognize that this must meet the ICC Evaluation Service Acceptance Criteria AC-14. And so you're going to want to verify that the evaluation report statement indicates that the joist meets the IRC requirements for membrane protection. Now, there's some question about the availability of this particular product. There's been some challenges to it out there in the work environment. So this may be a bit of a challenge for you to obtain. But the key is keep an eye out and look for the fact that it meets the ICC Evaluation Service Acceptance Criteria AC-14 that we've talked about. Another option that is also needs to be questioned very closely is what's called a field applied coating. Someone may try to market an intumescent product or some other fire resistant product that's sprayed on or painted on, much like you see in this particular question. Now, it's important to know, or this slide, it's important to note that these products are outside the scope of the ICC acceptance criteria. So they're not covered by that. So what you're going to want to do is verify that the I-joist structural and fire performance is not compromised with this by checking with the coating company or their particular agency. You want to make sure that the coating doesn't weaken the adhesive or the material fibers, the wood fibers in these products once it's applied either by spray or by brush or roller. You'll want to verify the evaluation reports and the application instructions with the local code official or the authority having jurisdiction to make sure that he or she is satisfied that this provides an equivalent level of protection. And of course, if this is used, it's always recommended that you have the documented justification for accepting this in lieu of one of the other recognized ICC acceptance criteria solutions. So the question is, which is better, automatic sprinkler protection or a passive level of protection? Well, at this point, the data are not there that really prove the difference between the two. So there's an effort going on right now to look at a large-scale survey to identify whether the passive or automatic sprinkler protection provides the better level of protection for engineered wood I-joist. So APA is looking into that to see what they can come up with for some additional recommendations. So to summarize our presentation today, we've talked about residential construction and wooden I-joists. They are obviously very popular in the market. They're growing. If you look at the data that APA and some of the home builders provide, is they become a much more prevalent product in the construction industry, and we'll continue to see a trend upward in their use. Like I say, even though they are more expensive than nominally sawn lumber, there is a cost savings associated with the design and installation features that they provide. We talked about the I-joist fire protection assembly requirements of the IRC. Essentially, anytime you have a exposed wood floor assembly that's protected by something or it's supported by something less than 2x10 nominally sawn lumber, you're going to have membrane protection or some alternative. We talked about preventing civilian firefighter injuries and deaths, and that's what this is really all about, is protecting the public from unwanted fires and early collapse. And we'll talk a little bit about the wood products industry engagement in firefighter safety. Now, in addition to this particular webinar, APA and the American Wood Council both are very involved in providing face-to-face seminars and training materials throughout the United States for firefighters and code officials and the general public to understand more about their products. We talked about APA's development and testing of their alternative compliance methods using the ES Report 1405 that verifies that these products do comply with the ICC Evaluation Service. And the System Report 405 gives those 7 prescriptive alternatives that a contractor or developer or carpenter can use to satisfy their requirements. Now, what else is out there? If you're in the fire service or just want to learn more about it, APA has some more information on engineered wood products and fire behavior. And you can find them at this website, www.apawood.org/fire. And they have some general wood awareness guides that you can download to learn more about the products and how they're manufactured and used. That can be found at woodawareinfo.org. Now, one of APA's partners, the American Wood Council, also has some information available at awc.org, code standards/fire. And they have a wealth of information to protect buildings under construction at their new website, constructionfiresafetypractices.org. So this concludes our presentation. And again, I want to remind you that you can get information on this presentation and others from apawood.org/fire. And if you have questions that weren't answered in this presentation and would like to get more information, you can certainly call the APA Help Desk at 253-620-7400 or log on and send an email to help@apawood.org. Thank you for your attendance today. I hope this met your needs and hope you attend other APA presentations in the future. Greg, would you like to finish up? Greg?
Thank you, Rob. I'm going to be asking some questions that we've had come in. But before we do, there's one question I wanted to get to first. Or actually, it's a comment from one of the participants who accurately noted that when you protect the underside of wood I-joists with a gypsum membrane, that you do not have to finish that surface. It's not required that it be taped or sanded or finished in any way. So that's an important detail that folks should understand, that ceiling does not need to be finished. Here's another question, Rob. The question is, where can I learn more about the ICC evaluation service process for evaluating wood I-joist performance?
Well, thank you, Greg. The ICC Evaluation Service, as I said, is a family company of the International Code Council. Their website is icc-es.org, and you can search there for acceptance criteria AC14, and it will provide you all that documentation for what we're looking for today.
Thanks, Rob. Another question. What other efforts is APA undertaking to reduce firefighter injuries and deaths?
In addition to this webinar, APA has worked very hard to put together actually a 3-hour version of this program that can be delivered in a face-to-face environment. And in fact, has been reaching out to fire services right now in New York, Colorado, Pennsylvania, Ohio, and Massachusetts, where they're offering to deliver this course for free, no cost. All they're looking for is somebody to host the class, and APA will provide the folks to get that. These states were picked originally because these states have a predominant number of single-family dwellings that are being constructed with basements, either full basements or partial basements, and so they're focusing the educational efforts there first. But it's my understanding APA intends to extend this program nationally over some point of time to be able to reach firefighters throughout the country.
Right. Thanks, Rob. Another question. Does APA have public education materials that can be shared with the fire service and home builders? And if so, where can I get them?
Absolutely. If you took a look at some of the web links that we had on the presentation, 2 of which will provide information about fire-rated systems and some additional information from webinars. If you go to apawood.org/fire, you'll find all the information that you need. That'll link you to all of the different programs that we talked about today.
Okay, Rob, another question about coatings. A manufacturer recently asked our building department to approve a coating for use on I-joists, claiming it met the code requirement for floor protection. In this case, is a flame spread test report adequate documentation for them to provide an approval?
Absolutely not. Flame spread is simply a measure of how quickly fire will spread across the surface of the surface. It's used typically for interior finishes, whether it be wood applied to walls or even the surface of the paper surface of gypsum wallboard. So it's really not a valid test to verify the fire resistance equivalence, if you will, or the fire performance, if you will, of a engineered wood I-joists. It's 2 different tests entirely. That's why it's so important to do your research, find the information that's out there, and make sure that you're making a decision based on the best information that you have at the time.
Okay, thanks, Rob. Another question. This one's about custom-made wood I-joists. And the questioner wants to know, can I get custom-made wood I-joists that are taller than those described in the webinar?
Generally, no. You can't order custom I-joists. Most common ones that are used today typically are Well, you saw one in the illustration there that was 9 3/4 inches, but they do range typically in depth from 11 7/8, 14 and 16 inches of deep, which are the ones that are typically used for residential and light commercial floor applications. The problem with trying to create a custom depth, if you will, or height, is it would have to go through all of the different engineering analysis and testing and performance requirements. So you're just better off to stay with the standard sizes.
Okay, that makes sense. Another question, are wood I-joists equally strong if they are installed upside down? How does the installer know which one is the top flange?
Well, builders typically have to, crown pieces during construction of I-joists, LVL laminated veneer lumber and laminated strand lumber. They can be installed regardless of which side should be up or down. There really is no top or bottom with the products. But I think it's worth mentioning that some of the glue lam beams, the laminated glue beams, where the faces of 2x4, 2x6 lumber are laminated together, they are available with a camber built in, which is essentially an arch, if you will, a small arch, which allows them to span those long distances that again, compensate for dead load and even live load deflection. These beams are referred to as an unbalanced beam. So their top side is marked with a top notation on it, which allows the beam to be under compression when those live and dead loads are applied to it.
Okay, Rob, here's a question that's not specific to I-joist, but I think it's an important question. And it is, how can I get involved in the code development process to express my concerns or support? And I take that to mean, relative to topics around I-joists.
Oh, sure. Well, of course, in the United States, the predominant building and residential construction code are the international codes. There are a few jurisdictions that use either local codes or National Fire Protection Association Code 5000 for building and construction safety. But in fact, both NFPA and ICC have open consensus processes for anybody to get involved. Now, the ICC code process is quite easy. Simply go to the ICC website, which is iccsafe.org. That's International Code Council safe.org. And look for a link at the top of the page called CDP Access. CDP stands for Code Development Process Access. You register with an email address. There's no cost to register. When you get on CDP Access, it's very comprehensive. This is where you see all code change proposals that have been submitted. People can submit their own if they would like to. There's an opportunity to collaborate with other people in that environment. And ultimately, that's where the votes are taken to make code changes that happen.
Thanks, Rob. That really wraps up the amount of time we have to address questions today. However, I want to remind everyone that questions and answers that we were not able to get to today because of time will be available with the recorded version of the webinar on the APA website in about 2 weeks. And again, this program is accredited by the AIA and the ICC for continuing education. Thank you to those, a link rather, to those certifications will be on the APA website in about an hour from now. So thank you for attending. Rob, thank you for the excellent job of presenting. I hope everybody found today's presentation valuable. Thank you.
Thank you, Greg.